In order to graph compound inequalities, we need to understand how to graph simple inequalities. So when we graph these, first we want to solve. So subtract 5, 2x is less than 2, divide by 2, x is less than 1. So let's go with 0, 2, 4. So this would be 1. It's going to be an open circle because of the less than. And it will be shaded to the left because x is smaller than 1. Here we subtract 5. So 2x is greater than negative 12. Divide by 2. X is greater than negative 6. We divided by a positive so we don't flip the inequality. So if here's 0, negative 2, negative 4, negative 6, there's going to be our open circle, and x is greater than shades to the right. So that's how we graph simple inequalities. Our goal is to graph something like this, where we're graphing, this is an AND statement saying that 7 is greater than 2x plus 5, and 2x plus 5 is greater than negative 7 at the same time. We're looking for the values that make both statements true at the same time. So a compound inequality is more than one inequality joined by logical operators. So AND is where both must be true. And OR, the mathematical meaning of OR is that one must be true. So for AND, we're looking at the overlap. So what part makes both of them true? Whereas for OR, we'll shade both together, because as long as it makes one of them true, it will make both true. So is x equal to 3 a solution to this? Well, 3 is greater than 1. 3 is less than or equal to 8. That's true and true, so yes. Is x equals to 16 a solution? So 16, no. No, it's not a solution here. So the answer is false to the AND statement. 16 is less than 1. 16 greater than or equal to 8. Yeah, it's true there, so that makes it true to the OR statement. As long as it's true in one of them, it's true in the OR statement. And 3 is less than 1. 3 is less than or equal to 8. That's false. That's, greater than or equal to 8. So this is false overall. Okay, so to graph compound inequalities, we will first solve each inequality, draw a number line that includes each of the important points. If it's AND, we'll shade where all inequalities are true, the overlap. And if it's OR, we'll shade where any inequality is true, put them on the same number line. So if we say x is greater than 1 and x is less than or equal to 8, we're looking for the overlap. So I'll do x is greater than 1 is going to be an open circle there, shading right. This will be a closed circle at 8, shading left. And we're looking vertically. Are both of them true? No. Are both of them true? 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 Ooh, here is where they start to both be true. Right after 1, they start to both be true until we reach 8. 8 is the end of where they're both true, and then only the blue one is true. So what's in red is your final answer. This is what I will expect when you graph this inequality. Usually people won't bother drawing this, and they'll just say, okay, the smallest point is 1, the largest point is 8, and it's between them because we're greater than 1 and less than or equal to 8. But that's how we get it. So x is less than 1. X is less than 1. Or x is greater than or equal to 8. So for an or statement, we're looking for what makes at least one true. So all these points make the blue one true, so they count. All these points don't make either true, and this makes one of them true, the green one. So that's our answer for the or statement. And we're looking at the overlap. For or, we're putting them both on the same number line. So here we had, I'm doing this kind of quickly, we had these two giving us the red answer. We're only looking for where they were both true. Here, we're looking where at least one is true. Now, if we say x is less than 1, x is less than 1, that should be an open circle, shading left, and x is greater than or equal to 8, so we'll have a closed circle shading right. The overlap there, well, here 1 is true, 1 is true, 1 is true. We need both of them to be true. Neither are true, neither are true, neither are true. Only 1 is true. So there is no solution. There is no number that makes both of them true at the same time. So the blank number line would be our answer here because there's no overlap. You're essentially never going to get no solution with an or statement because as soon as it makes one of them true, it'll make both true, or it'll make the overall statement true. So x is greater than 1 or x is less than or equal to 8. Now, when we're drawing this, well, this makes one of them true, this makes one of them true, this one makes one of them true, this one makes... Now we have both being true, so that's even easier. Now one of them is true, one of them is true, one of them is true, so the entire number line works. And we say all real numbers. So what did we do? Here, because we had and, we were looking for the overlap. Here we had or, and when you have or, you're plotting both. Plot both. And that should match with what I said on the previous slide. The overlap for and, both for or. So if we were to graph these, well, we would subtract 5 from both sides. 2 is greater than 2x is greater than negative 12. Divide by 2 on all sides. So 1 is greater than x is greater than negative 6. So let's put in negative 6, negative 4, negative 2, 0, 2, 4, 6. So we're saying it's x is greater than 6, or negative 6, and less than 1. So the numbers that are greater than negative 6 and less than 1 are here. If you wanted to do that the long way, what you would do is you'd say, okay, x is greater than negative 6 and less than 1. The overlap is here. Let's not forget to label our number line. All right, some examples. Subtract 3 from both sides. B is greater than 9. Divide by negative 3. Flips the inequality, so negative 8. B is less than or equal to negative 8. So let's go with 0, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. So B is greater than 9 or less than or equal to negative 8. That gives us a final answer of putting both of them on the same graph because it's an or statement. All right, divide by 4 on both sides. Inequality does not flip. Here it did because we divided by a negative. Subtract 5 on both sides. N is less than or equal to 10. So let's go with negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. We want to say that it's less than or equal to 10 or greater than or equal to negative 6. that's going to be all real numbers because it's everything. All real numbers. Can I spell? Yes, I can make it to the end. Subtract 8 from both sides, or all sides, I guess. Negative 3 is less than or equal to r is less than or equal to, oh, not less than or equal to, less than, goodness, less than 10. So we'll have negative 4, negative 2, 0, 2, 4, 6, 8, 10. Here's our open circle. Here's our closed circle. This one's closed. This one's open because this one did not have an or equal to. This one did. And we're shading between those two because r is between those two. Divide by a negative. So x is less than positive 2. And x is greater than positive 5. So it's less than 2 and greater than 5. There's no overlap there, so no solution. There is no number that's smaller than 2 and bigger than 5 at the same time. And last pair, need a little more space for this. Add 1 to both sides, so we get 3x is less than or equal to negative 27. For this one, we're subtracting 5 from both sides, so we get negative 8x is less than negative 8x is less than negative 56. Divide by 3. Divide by negative 8. X is greater than 7. This is an OR statement. So we have negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. We have greater than 7 or less than or equal to negative 9. Here, let's subtract 5. Oh, this is the same inequality there. Negative 8x is less than negative 56. The second one, we add 7 to both sides. So 3x is greater than negative 9. Divide by 3. X is greater than negative 3. Divide by negative 8, flipping the inequality to get x is greater than 7 and greater than negative 3. So we have x is greater than 7. So let's go with 0, 2, 4, 6, 8, negative 2, negative 4. X is greater than 7 would be from here to the right and from here to the right. Now this is the first time that we've had both of them facing in the same direction. So we go back to what and says. And said that we're shading where all inequalities are true, the overlap. So what makes both of them true at the same time? This doesn't make both of them true. This doesn't make both of them true. It doesn't make both of them true until we get here. So here, that is our inequality. X is greater than 7 is more restrictive than x is greater than negative 3. Thank you.